Hello everyone. We have been discussing about life cycle assessment and how to do it. Today we will see how to do this life cycle assessment using a software. So there are multiple numbers of tools, software tools, as well as nowadays there are also applications, apps available which can be used for doing life cycle assessment. So OpenLCA is a software which is a free software, and it also has lots of free databases. So you can go to OpenLCA, you can use CIMA-Pro or Gabi. CIMA-Pro and Gabi, both of them are paid softwares. SolidWorks, which is a 3D modeling software, it also has certain aspects of life cycle assessment into it. So when you have designed a particular product, and you allocate materials to that particular product, to various parts of the product, then you can do a life cycle assessment, and you can also make modifications to the materials that you have used. So say for example, you use material polyethylene, which is a plastic. Then you identify the life cycle assessment with polyethylene as a material, because polyethylene has different density as compared to polypropylene. So you will be able to have bottles, if you are making bottles of different weight with the change of the material, and as a result the life cycle impact will change for both the designs by changing the material. So SolidWorks allows you to do that kind of manipulation and see how to make a better product with the given considerations. But that is only for the product assembly that you have at that point of time. So it is more like a cradle to gate LCA. Then there are two apps. These are very lightweight apps, and you can use them on any Android or iOS based device. So the first app is called as IDMAT, and the next app is IDMAT Lite LCA. So the IDMAT, the first app, it had data related to lots of different processes. At this moment the database had some 700 materials and processes, and you could pick up all those materials that you require. Then there was an Excel sheet available which is connected to this app. You can put the required data in that particular app and then do your life cycle assessment calculations. But recently they have come up with a more better application. It's the IDMAT Lite LCA, in which in the app itself you can do life cycle assessment. So you can, for doing any kind of advanced level of life cycle assessment, it is very important to know how to use these softwares, OpenLCA or CIMA-Pro or Gabi, because they are very sophisticated softwares with lots of databases, country specific databases and so on. But they are very difficult to learn. So what we will do in this course is, our aim is that anybody and everybody should be able to do life cycle assessment on the go. So the IDMAT Lite LCA app can help you to do that. It is very simple to learn. So we will learn how to use that particular app today. So there are videos explaining both the apps, because the second app is built on top of the first app. So I would suggest you also look for the first app, the video related to it, and then also look at the second app and the video related to it. We will also do a demonstration now on how to do this life cycle assessment. So the IDMAT app, as you can see, it has two columns, rank on eco cost and rank on carbon footprint. So when you are trying to rank on the eco cost, it gives you more details, and you can also go on carbon footprint, which gives lesser amount of detail. But the benefit of this software is you can interchange. So if you are doing it with eco cost, you can at that point of time also change it to carbon footprint. So it's a very versatile application. So let's first start with the basics of this application. So let's first consider what we can't do, then we will see what we can do, and then go into the app. So what you can't do is, So, LCA of a system with byproducts. So, you know what LCA of a system with byproducts is. We discussed that in our previous lectures when we are trying to understand life cycle assessment. So, you cannot do LCA of systems with byproducts in this case. You cannot do complex end of life scenarios other than the 3 base cases. So, the 3 base cases in this application are landfill dumping ground, or waste treatment and open loop recycling, or closed loop recycling and co-firing. So, these are the only 3 end of life scenarios for which you can do a life cycle assessment. You cannot do it for more complex scenarios. But in most design cases, when you are trying to design new products and solutions, the facility which is being given by these 3 scenarios is good enough. Now, let us go to eco costs of USTOX tables. So, USTOX is a model to calculate midpoint characterization factors for human toxicity and freshwater ecotoxicity. Again, we do not need to delve a lot into this. This is something which LCA experts can go ahead with, and in case you are interested more in this topic, you can do further courses. So, all the software tools that I mentioned in the beginning of this course, all those tools have tutorials. Some of those tutorials are freely available. For others, you can subscribe to their facility on a payment basis. They teach you using those softwares and doing life cycle assessment. So, what you can do with this particular app is, you can do cradle to grave analysis. You can also do cradle to cradle analysis. You can do benchmarking the advantages of circular business concepts. You can benchmark the difference of innovative product differences. So, I make product A, product B and product C. So, I can compare the difference between these A, B, C and also from the existing context. So, that is why it says you can benchmark the difference of innovative product designs. You can also benchmark the differences in service systems. And finally, it can also help you to calculate eco cost for an environmental product declaration. So, that is meant for EPD declaration. But we will not go into the details of it, because the whole aim of this particular course is to help you in designing for sustainability. So, we are mostly focusing on the design phase of it, where we should be able to quickly decide between options. So, let us look at the app. So, the IDMAT sustainability inspired material selection app. So, when you first time start this app, again you have to be very careful. This app is there for all Android and iOS devices. So, you cannot use this application on your computer or laptop. So, this app is inspired by the IDMAT sustainability inspired material selection app, and it has been conceived by TU Delft, that is a university in Netherlands. So, this app is based on LCA calculations of more than 700 materials and related processes, and it is part of the IDMAT database available from Delft University of Technology. This database is not very comprehensive. So, many times you might find that data is missing. It is also not very region specific. So, there are few data points available which are for the Indian context, but not all data points for regional contexts are available. Then it consists of all the scores are based on selection process, which includes 3 end of life scenarios. So, you have the landfill scenario, you have the waste treatment scenario, that is the open loop waste treatment, and you have the closed loop, that is the circular economy scenario. So, if you look at these bars, what you can see from the bars, you can know what is the impact level, what is the eco burden. So, these bars try to show you the eco impact. So, the eco impact on this particular context is the lowest, and in the context of landfill it is the highest. Next, what you will see on this app is you can do the impact scores on two value indicators of your choice. So, the orange one, it is meant for eco cost, and this green box, it represents carbon footprint. It also has additional functionality, so you can list your favorite entries. Say for example, you are someone who designs a lot of products in plastic and you are into designing plastics for the FMCG market. So, majority of them are polypropylene, polyethylene and various grades of polypropylene and polyethylene. So, you might decide to list them as your favorite entries, so that you can reach to them much faster. You can choose your indicator, the end of life scenario, and set sorting options. We will discuss how they will do that. There is also, each entry offers additional in-depth information. Say for example, you are very new to this particular platform. You know you want to use plastics for your design. So, this platform helps you to compare all available plastics on its eco cost as well as on your carbon footprint, depending on what option you have selected, also depending on the end of life scenario that you have selected. Plus, it also gives all the mechanical properties, all the electrical properties and so on, which you might require to consider in order to put a particular plastic into your design. Hence, it is a very comprehensive app, and it is an extremely useful app for all students, because if you do not know so much about material, this app automatically educates you about all those materials. So, then there is entry specific web links to take you even further, and you can share your entry or specific data or your favorite with others. So, all kinds of sharing options are available, sharing through messaging, sharing through emailing, also all the LCAs that you do, you can share it. So, let us get started with this application. So, now we will do the demonstration of this application. So, as you can see, I have both my apps. The IDMAT app is over here and the IDMAT Lite LCA app is over here. So, let us open the IDMAT Lite LCA app and see how this app works. So, on this screen you can see, you can select whether you want to rank on eco cost or whether you want to rank on carbon footprint. You can see these three dots over here at the corner. So, if I click on those dots, you can take the tour again. So, if I say take the tour again, you go through the slides which I just showed you in the PowerPoint. So, you can also see, so when you first time install this particular app and you start this app, it is going to say that the database is old, please update your database. So, you should update your database. Currently, you can see the data version is 17 and the app version is 2.2. You can keep on doing the update app, but this app will also automatically update. So, every time there is an update available, it will do that job automatically for you. On the right hand corner of this app, you will always find an icon, either it is question mark or it is the symbol of settings. It differs from screen to screen. So, to know more about all these components, you can click on the question mark. So, when I click on the question mark, I can get to know what eco costs are and what carbon footprint is. So, let us have a quick recap. Eco costs are so called external costs to our society which are not included in the product price. Carbon footprint is a measure of the impact our activities have on the environment in terms of the amount of greenhouse gases we produce. So, which choice should you make? That's always an important question. When we go ahead, you can see at any point of the app lets you to change your choice. But let's start from one choice. But which choice? So the advantage of the carbon footprint is that it is easy to understand, because you know how many carbon dioxide equivalents your particular design features or the materials or the processes used is going to produce. The advantage of the eco-cost is that it performs well in the cradle to cradle and circular economy calculations, since resource depletion is included in the system. So, the carbon footprint, it does not talk about resource depletion, it only talks about the carbon footprint expressed in terms of CO2 equivalents. Whereas, if you select the eco-cost, it will also involve the eco-cost because of the carbon footprint, and it will also include resource depletion. Let us go ahead and we will know what it actually means. So, let us first select rank on eco-cost. So, once I selected rank on eco-cost, the next thing says is select your scenarios. So, I have the landfill scenario, I have the waste treatment and open loop recycling, and I have the closed loop recycling and co-firing. You can again see in this screen also you have a question mark. So, let us press the question mark and see what it has got to offer us. So, the scenarios presented here relate to the end of life stage of materials and processes. 3 end of life scenarios are distinguished. For the landfill or dumping ground, in this scenario it is assumed that material waste ends up in a refuse dump. Waste treatment and open loop recycling, in this scenario it is assumed that the material is processed in a modern municipal waste treatment system. The waste is separated with recycling of metals and incineration with heat recovery, electricity of plastics, textile and wood products. The closed loop recycling and co-firing, this scenario assumes that used products are taken back by the manufacturer and the materials are upcycled, that is reused without a reduction of material properties into new products. For wood, the assumption is made that it will be burned in a small local electrical power plant after reuse and downcycling of the clean fraction. So, now after reading this, we precisely know what is meant by each of these end of life scenarios presented in this particular app. Now, let us see what kind of difference comes depending on the data I am going to see. So, let us select landfill and dumping ground scenario. So, here you can see my first tab talks about favorites, the second one talks about LCA project. I also have a question mark over here on this tab. Then I have lots of materials and process. So, I have metals, common metals, expensive metals, rare earth metals, then I have polymers categorized as plastics and special plastics. I also have some textile materials. I have different types of wood. So, you can see the wood has been classified as class 1 and class 2 and as something which is 50 plus year and something which is 25 to 40 years or 12 to 25 years. Let us go, we will just discuss in a while what that means. Then we have building materials, electronics, other materials, packaging materials. In the processes, we have metal related processes, plastic processes, textile processes and wood processes. We also have data related to energy and fuels, transport. The EPD midpoints will be used in case you want to do a EPD an analysis for EPD. Then there are also databases for different kinds of food like vegetables, meat and fish, fruit, dairy, cereals and some other things. So, this is a very comprehensive list. Let us click on the question mark on the right hand corner. So, when you see the question mark, because in this whole list of materials and processes, what was not very clear is what this class 1, class 2 in the context of wood meant. So, this explains that. So, the following table provides additional clarification regarding the wood categories displayed on the previous screen. So, this classification is according to certain standards. So, class 1 implies very sustainable, class 2 is for sustainable, 3 for moderate sustainable, 4 for poor sustainable and 5 for not sustainable. Then you have two conditions, one is greater than 25, the other is greater than 50, that is in the context of class 1. In the context of class 2 again it is 15 to 25 years and condition B is 40 to 50 years. So, that is how the whole condition A and condition B is defined. What is the meaning of condition A? So, condition A is wood in constant contact with humid soil, not underwater and not protected. Condition B is wood exposed to outdoor conditions. So, it is not protected wood. So, depending on your usage context, you will know which particular category it falls to. Now, let us look at the favorites. So, when you click on the favorites, all your materials or processes or energy, whatever you have put in favorites will come up over here. Let us look into the LCA project. So, when I click on the LCA project, so here you can see you can start new LCA project and you can also look up your existing LCA projects. Let us say I have this one project over here and I can look at the project. So, if I see this dashboard, first you have to give a project name, then you have to give the description which will contain either your functional unit or declared unit. Then you will include all the material resources. So, I have PET, bio based, the unit is very important. So, here the unit is kg, then polypropylene, film LDPE. So, these are the resources. Then I have to put over here the measurement in terms of the unit which is present over here. Then my processes, so I have blow molding process, injection molding process, I selected the process responsible. Then I also need some truck trailer which is a 24 ton truck trailer and the unit over here is ton per kilometer, sorry ton kilometer. When we go into looking at each of these component, you will see that you can select two types of trucks. One type based on ton kilometer and another type based on meter cube kilometer. We will discuss about it little later. Again you put on the measurements, then in the use phase I again need another truck and trailer. So, I will again put data over here. When I am done with this process, you can press calculate LCA or that button also helps you to save it. I can also add an extra data line. So, say for example, let us press extra data line, you get your entire list of materials and processes and you can select from there. So, let us say I select a common metal and I want to use carbon steel. So, once I have selected carbon steel, you can see at this place there is something called as LCA and this is the icon for favorite. So, if I click on favorite, it will be added to my favorite list. If I click on LCA, it will be added to the LCA document which from where I came over here. So, let us click on the LCA. So, I clicked on the LCA, it says added to project and now let us go back using this particular icon, go back and you can see I have my carbon steel secondary in kgs added to this. So, if I add the measurement over here, say I add 1 kg and then I say calculate and save, what you get over here is the LCA output. So, right now, so because this yellow bar is highlighted, so you know that I am calculating eco cost. I can click on this green place. So, as soon I click on this green space, this bar becomes green and now I am trying to see the carbon footprint only. So, that is why I told you that this is a very versatile software and it lets you change your selections at multiple points of time. So, if I see the carbon footprint calculation, what it gives me is landfill related, because I have selected the end of life scenario as landfill. So, my carbon footprint of the landfill due to landfilling will be 5.7 kgs of CO2 equivalent. The due to waste treatment it will be 7.28, and because I am not going into circular economy, so unknown. And over here you get all the for individual materials. So, the landfill for the PET bio, so PET bio based is not like biocompatible PET. What it means is bottle grade PET. So, for each and every material I know from here the landfilling CO2 equivalent, then for each of the processes the waste treatment is, carbon footprint is given, and so on. So, if I scroll down I can see the whole picture. Then over here you can see you have an option to export the LCA. When I press on export LCA, so you can see there is this whole data, the entire output is given, and you can mail it to yourself. You can also delete this LCA. So, I have an option to delete my LCA. What is this duplicate LCA meant for? So, what duplicate LCA will help you doing is, say you want to compare two products. So, you want to compare between having polypropylene versus having polyethylene. So, when I do duplicate LCA, I will get another new LCA with all these resources, declared unit, everything the same. You change the project name over there to not have any kind of confusion. Then what I will do is, you can see these red crosses. So, I can cross the PET bio based and I can add the alternative material which I want to add over there. Similarly, I can do the same with processes. So, what it helps you is, you do not have to create the whole thing from new just because you wanted to check by changing the material. Always remember, changing the material, when you change the material you also have to change the weight, because a bottle, if it requires 1 gram of polyethylene terephthalate, does not mean it require 1 gram of polyethylene, because the densities of the material is different. You can produce different there are thickness related limitations. So, PET can produce very thin bottles, whereas the cross section of the bottle wall is very thin, whereas with polyethylene or polypropylene the wall cross section of the bottle is way much higher. So, you have to be also careful, like what will be, so that will be an alternate design, and you should know how much weight that will consider. Once you change the weight of the materials, you will also have to make changes in the transportation. So, let us go back. Now, let us look at these materials. So, say if you go to the material, say we will click on common metals. So, when I click on common metals, I get a list of all these materials. So, here on the right side you can see the settings icon. If I click on the settings icon, what you will have is an option to sort the results on alphabetical order, on the order of end of life impact. So, the first one is where you exclude the end of life impact and the rating, and then the second one is with the end of life included. So, say for example, when I look at this particular, because I started with my eco cost as the criteria. So, now since it is sorted on the basis of end of life included, I know that from top to bottom of the screen my eco cost increases. In case it is very difficult to find, because say you are looking for steel, now you have to look through the entire chart to find out where steel is. So, you can also sort it according to alphabetically. So, in that case it is easy to find, but they are not on the basis of the carbon footprint. Here you can also see that end of life scenario can be changed. So, what difference does come between selecting either landfill, waste treatment or closed loop recycling, that we will discuss now. Then you can also change your indicator. So, I am on eco cost, I can also make it carbon footprint. Let us make it carbon footprint, and when I say done, you will see all your data now is available on carbon footprint. So, let us go back again and then change it to eco cost where we were. Now, there are certain legends which we need to understand what it means. So, this first legend, what do these bars mean? So, it is the production in eco costs, size equals value. So, the size of the bar equals the value of the eco cost. Now, the image below shows bars expressed in single color, a yellow color if the eco cost indicator was selected in the previous menu or option, or it will be a green color. So, let us say if I select carbon footprint, it will be a green color bar. Larger the bar, the greater the eco cost or greater the carbon footprint. So, now coming to another kind of bar. So, here you can see two different colors. If I change it to carbon footprint, let us change it to carbon footprint, again you can see two different colors. So, this is production with added end of life. So, if since if I select only landfill option, so if we go back, so since I had selected the end of life option as landfilling, that is why you do not see that darker colored bar over here. Let us change it. Let us make it closed loop recycling. So, I will have to add the impact caused due to bring in that closed loop recycling. Then you will be able to see this darker color bar. What it implies is, the image displayed below shows a bar featuring a darker part at the right side. This part resembles the attribution of the chosen end of life scenario, which here results in additional impact which is added to the total score. So, let us go back to our list. So, you can again see. So, not necessarily everybody will have a say for example, for certain things we do not have that darker zone. Let us again change it to carbon to eco cost and look at this particular list. So, this is how my list is looking like. If I go into the waste treatment one, this is how my list is going to look at. Let us look at the plastics, which will be give greater clarity. So, here you can see when I look at the plastics, there are some of these have this darker zone. What it implies is production with added end of life. There is another kind of bar which says production with subtracted end of life. In case you can use that, say for the metals, this is the context that you saw, all of them had grey bars. So, when I do a closed loop recycling, they have a closed bar because of the production with subtracted end of life, because I am in a closed loop and I am taking back recycling that metal back into becoming metal without loss of properties. So, the image below equals a variant on the case described above. Here the attribution of the chosen end of life scenario yields an environmental benefit or credit, which can be subtracted from the total impact score. The amount of subtraction is visualized in a light gray color as to hint to a part that is taken away, while the resulting impact remains in its original color. There is also a third scenario, which is a pattern indicates value conversion with a logarithmic scale. So, the hashed pattern visible in the bar below indicates that a 10 log operator was applied to the ranking scale of the materials or processes belonging to that particular category. The operator is only applied to the scale of the visualized bar and does not influence the score of the entry itself. This modification allows for more distinction in the visual representation of bars belonging to a category featuring a wide range of scores. So, if you see at the end of this particular, so let us go to plastics. So, if you see some the last one, if it has this kind of a pattern, then it implies that it is on a logarithm, but it is only for the visual purpose. It is not done on the final value. So, the final value will remain same. So, in the context of metals, there is another aspect which needs to be considered. So, if you go through this list of metals, you will find that, say, chromium has, I have chromium over here which says chromium CRM virgin. What does this CRM stand for? So, when I go into chromium, you can see in information 2, it is information on scarcity and criticality. So, CRM stands for criticality of rare earth metals in terms of geopolitical considerations. So, let us see, I clicked on that particular thing. So, here you can see scarcity and criticality ranking. No bar means not scarce or not critical. So, the green one is for recycling or substitution percentage required for 1000 years of supply. The orange one is supply risk index, and CRM, the critical raw materials with geopolitical risks with sustainability index. So, there are certain materials, certain metals which have this CRM related risk. So, you should see whether, so because of the geopolitical risks involved, it might be better to consider how are you going to use those metals. Now, let us see what this whole, so if we go into any of those metals, first what you will see is a picture which depicts the kind of application that you can do with that material. The eco cost, so when I am in this orange bar, I am looking at the eco cost. If I click on this green bar, I look at the carbon footprint. So, let us look at the carbon footprint. So, for this chromium, the carbon footprint, it is due to the material, it is 26.26 kg. For the landfill dumping ground, it is 0. For waste treatment and open recycling, it is 0, and closed loop recycling and co-firing, it is unknown. For material end of life, again 0 carbon footprint. For hence, the total carbon footprint for the material is 26.26 kg. Now, let us click on the eco cost. So, now you can see how eco cost gives you much more information than carbon footprint. So, the red is resource depletion, the blue over here is ecotoxicity, the yellow over here is human health, the green is for carbon footprint. So, the eco cost because of the carbon footprint. So, all the costs are mentioned. So, if you see at this particular bar or you see at these values, you already know that the highest eco cost for this particular material is because of the carbon footprint. So, as we discussed earlier, eco cost gives you an additional idea related to resource depletion, which is not covered within carbon footprint. So then you get the total. So say for closed loop recycling and co-firing, I get a credit of 0.74 euros. So then you have material end of life and total material from here. So here you can see you have information 1, so design information 1. Let's click on the information 1. You have to have some working internet connection because it goes to that particular website and gives you the information. Your information 2 was on scarcity and criticality CRM, which we already saw that. Since this application is still under development, so there is no information of supplier, but soon there will be information on the same. This is the identifier name for this particular material which is used in the databases. Here also you have a share button which will help you to share the material with your email ID or messaging or any other such possibility which a normal mobile or tablet offers you. Now let's look at the plastics. So if I go into plastics, you will have so you can see PE bio-based. So whenever you see bio-based, it's not about biodegradable, but it's bottle category. So again here you can see the image, it shows that you can make these kind of bottles. Of course you will have many other functionalities also. So I have the same thing over here, eco cost, carbon footprint. I again have my information, design information. So when I click on the design information, again it goes to a particular website which tells me about the what this material is all about, the mechanical properties, the thermal properties, other material properties and common calculations which are in with respect to this material. Then you can have more and more information about this particular material. It also has a link. So the information 2 over here also has a link to Wikipedia, which also gives you more information at the same location. Let's go to the processes now. So let's go to a particular plastic process. So if I go to a particular plastic process, so say for example this is blow molding for bottles and this is blow molding for PVC film. So if you want to make bottles, the process is blow molding. If you want to make PVC film, again the process is blow molding. But because both the processes have certain differences in terms of how it is working, and hence you should select an appropriate option. Say for example, I want to do blow molding of not PVC film, but say linear low density polyethylene. What do? I do not have data over there. So what I do in such context is find out the situation which is most similar to that particular situation. So because it's film and I need to blow mold it, so I can take the data which is blow molding PVC film. Similarly, if we go into the energy and fuels, so energy and fuels is very important to consider. You have to remember that this is not a very exhaustive list and it's not geographically contextualized. It's more from the European Union context because TU Delft is located in Netherlands. So taking into consideration that, so say for example, if I click on hydroelectricity, you can see hydroelectric power generated in Norway. So the data which is for Norway is not actually similar to what we will have to consider for a hydroelectric power plant in India. But again, because this is an approximation and it's very easy and simple to do it, we are going to use this particular data for the given reason. Whenever you have to use electricity in your life cycle assessment, you have to be very careful. Say for example, when I use electricity from the main grid, that electricity in India is produced by thermal power plants, by hydroelectric power plants, by nuclear power plants. So you have to know that what is the mix of energy. So what percentage of energy is produced by thermal power plants, what by hydroelectric power plants, what by nuclear power plants. So, you can easily use you can find this data online for say India, you can find that data, and then from here you can select all those categories. So, I can select electricity from hydel source and electricity from gas and all those things, and when I am assigning those quantity. So, if for my entire process I need 100 watt hours. So, I will say if I know thermal power is 70% in India. So, out of that 100 watt hour, 70 watt hour will be the quantity in the context of hydroelectricity. So, that is how we try to solve this energy related issue. So, energy is always, electricity is always a mix wherever you go. Then you go to transport scenario, you have different kinds of transport scenarios. So, you have to see which one is applicable for you. In more sophisticated softwares like Gabi, Sima Pro, you have the possibility to change the kind of fuel mix that you use for running your vehicle. So, truck trailer which is 24 tons. So, if you do not know what a truck trailer is, 24 tons, when you go into it you will see the picture of it. So, say you the fuel mix used by a truck trailer in Europe is very different from that used in India. So, these more sophisticated tools helps you to also input what is the fuel mix, but for our very simple calculation we do not need to bother about so many complications. So, that was about using this particular application, how to use this app. Now, we will go back to our life cycle assessment. We will go through each and every step and we will do a life cycle assessment. So, what are the steps for LCA? So, the first step for LCA is establish the scope and goal of your analysis. This step might be done after step 2 in case it is a total new design. We have already discussed about it. Then we establish the system, functional unit and system boundaries. We quantify the materials, use energy, etc. in the system. Then we enter the data into a computer program. In our case, we will enter it into this particular app. Then we will interpret the results and draw our conclusions. So, in the context of design, you do step A, describe the system and the system boundaries, then you define the functional unit, then define the goal and scope of the study. When you do the same thing for reporting after all your design is finished, you will define the goal and the scope of the study. So, you will go the reverse order, define the functional unit and describe the system with the system boundaries. So, let us see how we establish the scope and goal of our analysis. So, this step might be done after step 2 in case that it is a total new design. So, when we are trying to establish the scope and goal of our analysis, our approach can be either we want to compare 2 or more products. So, when you get the eco cost or the carbon footprint of a product, that information per se makes no meaning, makes no sense, until and unless you do not compare it with other products. It is an attempt to improve the environmental characteristics of a typical product. So, I know that after doing an LCA that the impact at resource depletion level is very high. So, my aim is to improve the environmental characteristics of that design on that particular aspect. So, less or less harmful materials, less energy in the use phase. So, it depends after doing my first LCA what do I identify as my aim for improvement. Less transport, better recycling or better incineration of waste for electricity, cradle to cradle solution, better durability. So, now we will take this example of comparing a PET bottle versus a polyethylene bottle. So, as we discussed, our step 1 is to establish the scope and the goal of our analysis. So, out of all the possible in establishing the scope and the goal of our analysis, we decide that we will compare two products. How we distinguish between the two products is because as we had already discussed that the functional unit or the declared unit has to be same, the product should be comparable. So, we are going to compare this PET bottle and PE bottle on a functional unit which is same for both. So, let us see what. So, once I have established like what do I want to do, I want to compare these two. My next task is establish the system functional unit and system boundaries. So, what we do in this case to do this is first we describe the function of our product or service. So, say for example, a coffee machine which makes 1000 cups of coffee per year can be our definition of the function. So, like we discussed already, it can be a functional unit or it can be a declared unit. Then you make a drawing of your product system. So, you will consider whether you want to do a cradle to grave or cradle to cradle or cradle to gate, what kind of analysis. Then you determine the lifetime of the system components. Next, you will establish one or more transport scenarios, example coffee pods traveling from Thailand. Then the next step is you establish the system boundaries. So, let us see how to do it in the context of the example that we have taken. So, we want to compare a PET bottle versus a polyethylene bottle. So, let us first try to draw the what will be the components of this particular system. So, in this particular context you can see that my bottle assembly pack is going to consist of certain components. Before that, let us look at the declared unit. So, my declared unit, because the function should be same. So, my declared unit is for carrying 1 liter of water. I have to also determine a transportation scenario. So, the transportation scenario is made in Ludhiana and used in Ahmedabad. You can define appropriate transportation scenario. Why where it is made and where it is used is important, because that determines the distances, that determines how will it travel. If it is like has to travel over sea, it has to travel over air, or it can do land transportation and so on. So, keeping that declared unit, I talk about my assembly of bottle pack. So, it will consist of the bottle itself. So, in case of the polyethylene terephthalate PET bottle, the bottle will be made of PET, that is the plastic material, and it will be made by a process called blow molding. Then the bottle will have to have a cap. So, my bottle cap, and I will make it by injection molding, and it will be made with polypropylene. Then the bottle packs will have to be packaged in secondary packaging, so that it stays safe during transportation. So, that packaging will be made up of shrink sleeve, and the material which will be used will be LLDPE. Also, in the bottle I will have to fill up mineral water, and the mineral water will be purified using a 12-step purification process. Now, let us see how this whole system will look in the context of the polyethylene bottle. So, again my declared unit remains the same, that is 1 liter of water made in Ludhiana and used in Ahmedabad. So, I have my assembly, which is the bottle pack. Now, my bottle is going to be made up of polyethylene. The process remains same, that is blow molding. I will also have a bottle cap. In this particular case, my bottle cap will be made up of polyethylene. So, if you compare these two steps, what you see is that the difference lies over here, that is PET and polypropylene used for making the bottle and the bottle cap, and in this particular context it is polyethylene bottle as well as polyethylene bottle cap. Again it will have packaging, the packaging will be made by using LLDPE, and it will be the LLDPE film will be made by using blow molding process, and it will be put on the on those packets of bottles. So, like 12 bottles kept together by using the process shrink sleeve. Then I have water into it, which will be purified using the 12-step purification process. Now, let us see how do I, my step 3 comes over here, which is like quantifying the materials, use, energy, etc. in your system. So, in order to achieve the life cycle assessment, that is eco cost assessment as well as the carbon footprint, I need to now understand for each of these steps what will be the amount of polyethylene required for packaging 1 liter of water, what will be the amount of polyethylene required in the bottle cap for packaging this 1 liter water, and similarly what will be the amount required for the polyethylene terephthalate bottle. In this particular context, we will, when we are talking about the transportation, we will also have to talk in terms of either tons kilometer or meter cube kilometer. So, any particular truck, it has certain limitations in terms of the volume that it can carry. So, there is a maximum limit to that, the volume that it can carry, and there is a maximum limit on the weight that it can carry. So, whichever reaches first, the volume limit or the weight limit, that becomes the limit for carrying that particular product for that particular truck or container. So, we have to first figure out that for the context of our bottles, which are like each bottle is also filled up with 1 liter of water, and we consider certain kind of trucks in which I will be transferring my product from Ludhiana to Ahmedabad. So, what will be the best unit when we are doing this quantification in our life cycle assessment? And accordingly I will select the unit and then I will quantify the material. So, you will collect or measure data like weight, materials, energy consumption. Then you will determine the accuracy and relevance, establish allocation rules and cutoff criteria. What does this allocation rule imply? So, allocation rule implies, say for example, I am producing in the same factory bottles, toys and some other products. So, now there is certain energy consumption which is happening because of the production process. So, the blow molding machine is consuming certain amount of energy. That part is already absorbed in the blow molding process itself. But apart from that, because you are having human beings who are doing your work, you have lights in the factory, you will also have some associated offices where there will be energy consumption. Now, your factory, if it was only producing your bottle, so all those extra energy which you are using to run your office, to run your factory, it could have been put onto your bottle context. But now that is not true, because most factories make more than one type of product. So, in that particular context, you have to determine. So, if I consume 100 units of energy, if I consume 100 units of water for operating my operations and I have 5 different products, how will I allocate the energy and other such resource consumption onto each of those products that I am producing? So, that is meant by the allocation rules or scenarios. And then the cutoff criteria. My next step is I enter the data into a computer program. So, we will shortly see entering all this data into the computer program. So, if an indicator value, so when we are trying to enter this data in the computer program, we might come up with certain issues. So, if an indicator value for a material or process is missing, you can use one of the following strategies. First, you can ignore the material or process if its impact is insignificant using the cutoff criteria. So, what were the cutoff criteria? We already had a discussion on our cutoff criteria. So, you can neglect items from LCA in general on the basis of weight. So, if your weight is less than 1% when the list of total number of items is less than 20, or if it is, if the total of if the weight of that particular item is 0.5% when the list is between 20 to 40 items. So, say for example, in the PET bottle context that we considered, my bottle consists of the bottle body, the bottle cap, the packaging shrink sleeve and the water into it. So, there are 4 items. Now, if I have to neglect something, I can neglect something if the weight of something is 1%, because in this particular context I lie in this category 1% when the list is less than 20 items. 0.2% when the list is 40 to 100 items, 0.1% when the list is 100 to 200 items. Then 0.05% when the list is 200 to 500 items. Also, you have to be very careful about this exception. When there are some items in the list which are extreme toxic, which is normally not the case, since toxic materials should be always replaced and should not be used. But in case the item that you think lies under this rule, but is very toxic, then you should not be neglecting it. So, let us see in our particular context, as we discussed that we have 4 components: the bottle, bottle cap, packaging and the mineral water. The LLDPE shrink sleeve film, if I take the weight of that with respect to the total weight of the body, comes out to be less than 1%. So, I might reject it, but do that only when your data regarding that domain is not available. In case data is available, just put the data into it and see if it creates any significant amount of impact. Now, the next thing about entering the data in the computer program, you will substitute with a known similar process of material the unknown process of material. So, as we discussed in the data, we had blow molding for PVC films. Now, in the example that we have taken, we have to do blow molding of LLDPE to manufacture that. So, because that is not available, so I will substitute it with the known example, which is, so instead of blow molding of LLDPE film, I will use blow molding of PVC film. You can get an expert to calculate the same for you. So, an expert might use more advanced softwares like CIMA Pro and Gabi to calculate that for you if you want to be very sure about the value. You can take the required energy for the process, calculate the eco burden of it and add the eco cost of the extreme toxic emissions, if any. That is also a possibility. Then finally, so you will get some values, like when we were trying to understand software, we saw that whatever if we put some inputs, you will always get some output related to eco cost and related to the carbon footprint. The values as such make no sense. The values will make sense only when you interpret the result and draw your conclusions. So, how do you do that? So, you analyze the eco costs of your product with respect to other alternative products or designs, and then you get your results. So, let us see how we will do this 5 steps on our software. So, we will take our context, we will go to, first we will start from our system definition. So, our system definition was for the PET bottle. So, I have my flow diagram available to me. Let us do a eco cost analysis. So, I will do rank on eco cost. the scenario that I have selected for the given LCA analysis is landfill. So, the end of life scenario I will select as landfill. Then I will start creating a new LCA project. So, here is my creating a new LCA project. So, let us create the new LCA project. So, I will say start new LCA project. So, if you have already have an LCA project open, it will ask you the question whether you want to close it first or not. So, you can close it. So, you can see I have project name. So, let me put a project name which will make it recognizable enough. So, I will say PET bottle polypropylene cap. Then I have to write the description. So, in the description I will talk about my declared unit. So, my declared unit in this context is 1 liter water made in Ludhiana and sold in Ahmedabad. So, now the project is created. What I will do is the next step, when I will say add extra data lines, this will help me to add all the materials and processes. So, let us say add data lines. So, my first material that I have to add is PET. So, I go to plastics. In the plastics I will try to find out PET. So, here you can see this is PET bio-based, which is the PET meant for making bottles. So, it is not biodegradable or bio-based plastic. What it means is it is a bottle grade plastic. So, I will select this option LCA. So, I click on LCA, it is added to the project. Then my next product to be added is polypropylene. So, I will try to find out where is polypropylene. You can see here it is written polypropylene 30% GF. So, this if you are confused that this is my one that you want. So, see, this is not the one that we are looking for. What it implies is polypropylene filled with 30% glass. So, that is a composite. So, what I am looking for is only polypropylene. So, here is my polypropylene, the thermoplast which I am looking for. So, I will click on polypropylene and I will again add it to my project. Now, my another material is LLDPE. So, LLDPE is over here and let me select LLDPE and add this to the project. Now, I have added all the materials. Let's add the, so we will not consider the water component over here. We could have considered the water component over here, but unfortunately the database does not have water and the 12-step purification process that is carried for making mineral water. So, we cannot add, and anyways it will not make much difference, because here in this context what we are trying to do is compare PET bottle versus polyethylene bottle. So, if you remember the concept of streamlined LCA, all we need to do is, even we do not need to calculate for the LLDP, all we need to do is calculate for the ones which are different. So, for this case I need to only calculate the PET PP versus the PE. But still I have added the LLDP because I am interested in seeing what is the degree of importance of that category. So, I added that. Now, all my materials are added. Next I will have to add the processes. So, I will go to the processes. Here you have plastic processes. So, let us click plastic processes. So, I need blow molding of bottles. This will be applicable both for my polyethylene terephthalate bottle and polyethylene bottle. So, I added my it to LCA project. Then because I have a film, so I need the blow molding of PVC film, which is the approximation for the blow molding of LLDPE. So, I select that particular option, again press LCA, added to project. I have to do injection molding of my cap. So, I will select injection molding, again press LCA to add to the project. I need shrink sleeve, but shrink sleeve is not available over here. Let's see, is it available in packaging materials. So, if I click packaging materials, and I will have to, so you can see it's very difficult to search in this particular manner. So, let's sort it alphabetically and try to see if shrink sleeve is available somewhere. So, you can see there is film LDPE 50 microns, which is a very close thing. So, let's add this one as a process. You can read more about those processes to understand what exactly is covered in the LCA calculation. That will give you better idea whether you need to select that process or not. Then I need to add some amount of transport. So, let's add transport. Why I am adding transport? Because both my PET bottle and polyethylene bottle will have different weights, hence the transportation will be important to consider. So, let's look for, let's say our product is going to travel by a trailer truck. So, you can see that I have an option which is meter cube kilometer and ton kilometer. So, the first one talks in terms of volume, and the second one in terms of the weight that it can carry. Say for example, in our context, let's say that the ton kilometer is a more applicable unit. So, I will select this and it gets added to my project. So, now let's go to my project and have a look at what all it has. So, you can see that I have all my materials added, I have all my processes added, transport is added at the process level as well at the use phase. So, this is when it needs to travel in the use phase, and it is when it needs to travel in the processing phase. So, now we will put all the values. So, the values can be put over here. So, let's say for 1 liter of water to travel, I need 1 gram of PET. Now, my unit over here is kg. So, I will convert this gram into kgs. Now, say for my polypropylene, I need also kind of 3 grams of polypropylene. So, I will add polypropylene, then the weight of LLDP will be extremely small per bottle. So, if like 12 bottles are used in to be packed together, then you will divide it and put that value. So, now you can see it's very important to know actual weights and measures that are going to come for your product. Only then you can do any meaningful calculation over here. Okay, so like you can see, when we were looking for the materials, we selected polyethylene LLDPE, but we also found something which was the process plus material included together. So, at this point, let's say we will delete this one because we have a better option available. So, I will delete it. I will also delete the blow molding PVC film option from here because they are no longer applicable. So, let's put the value over here. Now, you will again put the appropriate values for these manufacturing. In the truck and trailer, you will put how much ton kilometer is to be carried. So, let's say I am going to carry 1 ton kilometer. In the use phase, again I have to say what it will be. So now I will do calculate or save LCA. So you can see all the, so the eco cost for our declared unit is coming out. For landfill is 0.06, for waste treatment 0.07 euros, for circular economy it's 0.06. I can click on the green and also see what are the, so in detail I can see the impacts over here. Now let's use the duplicate LCA, because I do not want to repeat the whole process again. So I will say duplicate LCA, and here I will change it, the name of the file. So this is my PE cap and PE bottle. Now I will replace the materials which I do not need, and let me put extra materials which I will be requiring. So now I am going to make my bottle out of polyethylene. So you can see this is the polyethylene which is for making bottles. So I will add this material. Then I also need to find the polyethylene which can be used for making the caps, and that is the same kind of polyethylene. So let's go back. So I have my polyethylene over here, because it's used for making the cap as well as the bottle. It will be the combined weight. As we already discussed, if I replace polyethylene with PET, the weights do not remain same any longer, because of the cross sectional differences in density. So say the total weight of the product will be now 10 grams rather than what we started with 1 gram. A part of this will be used to make the bottle. So let's say half of it is used for making the bottle, so I put that in blow molding, and half of it will be used for making the cap part of it. So I put that in injection molding. Because my weight increased so much in for the bottles, that for the truck and trailer will also increase. So let's add. Right now I am adding values arbitrarily, but in practice you have to find out the actual values and add them. So now I can again do a calculation of this particular process. So you can see all the eco cost, the carbon footprint of different materials, of different stages, of different processes, and you can export this data. You can export both of the data. If I go back, you can see I have all my data already saved. So at any point of time you can go back to your previous data and work onto it further. So this is an extremely simplified version of doing a life cycle assessment. It makes life cycle assessment easy and accessible to anybody and everybody, and it just takes no more than 5 to 10 minutes to complete this. But if you want to do a more exhaustive life cycle assessment, you need to develop skills in using, say, the OpenLCA software, CIMA Pro or Gabi software. So in the next lecture, what we will be discussing about is how do we design keeping into consideration this life cycle assessment in mind. So thank you till then.